Thank you everyone for joining us today from wherever you are. My name is Graham Hargraves. I'm the Strategic Business Manager for CAD-CAM Consulting Services. We're going to talk about ROBOZE today. So basically, we're going to go through a little bit of an intro, what we're going to talk about, then we're going to talk about what we're going to talk about. With ROBOZE, it's line of machines, materials, and how it really applies to subtractive shops. Then we'll wrap it up and open it up for questions. So the real reason we're doing this is a lot of our audience is traditional subtractive machine shops. Mastercam users, whatever CAD-CAM system you're using. What's the benefit of looking at and employing additive into your shop? And in this case, how can you realistically use plastics to replace metal? A lot of skepticism around that, so we want to kind of debunk some of the myths out there. So with us today is Axel, our additive manufacturing lead, Rob, our technical applications director, myself, and Levi Smith from ROBOZE. He's the global director of channel. Just a little housekeeping. This is a 1-hour webinar. There's a chat function if you have any questions as we go along. We'll be sure to address them all by the time we are done. Try to keep them appropriate, please. And then we'll have some follow-up if you're interested in ROBOZE and what we're talking about, have any additional questions, want to see the product or anything like that. We'll have contact info at the end. We are recording this, so that will be available on our YouTube channel. And so please make sure you're muted, your camera's off. That way we don't have any interruptions. And like I said, Q&A, just type it into the chat and we'll address those. So who are we? We've been around since 1993 in Southern California, surrounding areas. We have lines of additive machines and services, subtractive with Mastercam, a few other products, inspection, manufacturing, software, and hardware solutions. So with additive, we have Desktop Metal and what we're here to talk about today, which is ROBOZE. We have on the subtractive side, CAM Assist and Mastercam. Also Mastercam probing, which I'm not sure if you saw the news, but Simco was acquired by Mastercam just about a week ago. Mold Plus and Vericut. And then on the inspection side, we have VeriSurf. So we are local, we're experienced, we're dedicated staff. We have 3 offices in the area, and all of those offices offer training. And we also have online training if you're interested. So all of that really means we know your local community, we know the players in the area, and it's really our goal to make you successful. So closed loop manufacturing, if you're not familiar with this concept or haven't seen it, it's kind of what we've been pushing out there. It really ties in all of our products. It's the process of moving a single part and a single file through the entire manufacturing cycle from art to part. This is real world tested. We will get into that with this putter. With this putter, we wanted to make something that was, kind of recognizable, usable, real world, whether you're a golfer or not. We took an existing putter and we scanned it in with VeriSurf. Then we 3D printed the putter and we made some fixturing with ROBOZE. Then we brought it in and we did some CNC programming, which is where CAM Assist and Master come into play. Wanted to make sure it ran perfectly on the machine with Vericut. Before, during, and after machine probing as well with formerly Simco, now Mastercam probing. And then once it was all said and done, we wanted to make sure it came out exactly the way we wanted it with VeriSurf. So we do offer all these products. This is an actual thing that we did. Sad to say, it did not make me a better golfer, but I'm working on that. So we're going to jump into the ROBOZE portion now, and I'm going to turn it over to Levi. So
Terrific.
just take it away. Thank you.
Graham, I appreciate the introduction there, and again, really excited to be presenting today with our partner. And I think this is something I always touch on, right? So, in additive, I've been in additive for close to 7+ years now, and I've been working with really good local channel partners, and this is always what I'm looking for: someone who's got the knowledge, the capability to deliver agnostic solutions on the market. And CAD-CAM was really high on my list. So the opportunity to partner with them, work with them, and ROBOZE was really exciting. And so, I wanted to touch there as well. If you guys have, potential manufacturing problems, CAD-CAM has an excellent suite of products to deliver an agnostic solution for what comes up on your side. So, that is always what I'm looking for, working with great partners who can extend the experience of, a company like ROBOZE into their customers and do it in an agnostic way and develop kind of, solutions. So, with that said, excited to present today. And what I want to do is introduce ROBOZE, right, in a couple of ways: what we do well, and how it applies to the job shop. That's really what we're going to get into today. Next slide, Graham. So just a quick introduction on ROBOZE. I'll start here. We've been in the business of additive manufacturing solutions for roughly a decade now. We started back in 2014. And our main goal was twofold. One, we wanted to develop a solution that was very repeatable based on the manufacturing environment. And two, we wanted to work with the essentially super polymers and super techno polymers in traditional metal replacement. And that was kind of our big goal: is, can we get out there? Can we kind of showcase what this technology can do on a couple of fronts? A machine that is as close to what you get in a CNC process as you can with an additive manufacturing technology, and two, with some of the, focused on the most extreme version of advanced technopolymers possible. And this is just a range of our customers that we work with. We work with them on a couple of fronts. Obviously, they have our hardware. They use our materials. We do a lot of technical partnerships with them. And our big focus is on highly regulated industries. Next slide, Graham. So just to give you a profile of kind of where we work, again, a lot of our work is in very regulated industries. And this is just a couple of bullet points in each vertical of what we're approaching in terms of, kind of the business case, the engineering problem that we're working through. And there's a tremendous amount of work that goes into this, right? If you look at the energy sector, um, there's more or less two or three different approaches, right? If you look at energy offshore, making sure that operation is running can cost close to $1 million a day. Aerospace, we're really looking at lightweighting. Lightweighting is a big component in aerospace. And I apologize, I have a Amazon delivery. My dog is barking in the background. I apologize on that. This is the range of industries we work within. And traditionally, what we are doing, what we're focused on, is these application problems and replacing traditional metal applications with advanced polymers. And we're doing it in the most regulated industries out there. Next slide, please. And in terms of metal replacement, I have three materials that we truly focus on over at ROBOZE: Carbon Peak, PA Pro, Ultim 9085. Today, the application is going to be around our Carbon PA Pro, or PA Pro. And what we're really focused on with these end users and their application problems is metal replacement. And on the right, what you'll see is just tensile strength. PA Pro is the light blue there, but you have our top materials in there, right? Compared against aluminum 3031. So excellent strength in terms of tensile strength, excellent strength to weight ratio. And this is a lot of folks are looking at these advanced polymers as a potential replacement for the traditional metal component that they're working within. The added benefit, of course, with these advanced polymers is corrosion resistance. So we're replacing a lot of metal on offshore rigs. We're going into highly corrosive environments, a lot of pressure, a lot of heat, and these materials are standing up to those environments. So that's what I really wanted to touch on here. Graham, next slide. In terms of the range of materials, I think this is an added benefit of what we do over at Robo. So traditionally, those six materials you see on the to the right, from PA Pro to Tooling XCF, this is the major book of our consumption, the main materials people use. But you have a lot of versatility with the Robo's platform. So Carbon Peak, Tooling XCF, Neat Peak, Ultim 9085, whether it's amorphous or semi-crystalline, that tends to be the majority of our business. And what we're looking at is high heat environments, continuous use temperature of over 300 degrees Celsius, high strength, getting into 250 to 300 megapascals in terms of tensile strength, and lightweighting, right? Making sure that, this semi-critical component on the landing gear for Leonardo is, a kilo to 2 kilos lighter, which can represent thousands, if not tens of thousands of dollars every year. And we can do that based on the advanced technopolymers we use. So it's really about the materials at Robos, and it's really about creating a repeatable mechatronic process with our platform. Next slide. And just to give you the range of platform that we wrap these materials around, the Plus Pro is kind of our entry. You can actually see this at CAD-CAM. They have this running in their shop in Anaheim, but this is the entry level. We really distinguish our platform based on volume, right? So you have the Plus Pro as the entry. It's great for prototyping, small production runs with smaller parts. The Argo 500 is our flagship. This is the one you'll see the most out in the world. But it's got a build volume of 500 by 500 by 500. And we just recently launched the Argo 1000 last year. Again, I'm very excited about this. This is a bit of a pivot from our traditional technology, but it's a meter cubed in terms of build volume. And again, what you see on the screen here is a precise, essentially production tool. Very similar to what you see in a job shop, very similar to a CNC machine. I'll touch on just a quick kind of snapshot on the technology, what drives these machines. Graham, next slide. So one of the big things when I'll go back to kind of the origin story of Robos. Our founder built his first printer when he was 17 years old. He was working in his father's job shop, and he was thoroughly impressed by the technology when he built his first 3D printer. He did see limitations, right? One of those being the process of maintenance or repeatability. And so one of the first things he thought about when he developed this platform was a mechatronic process. For us, it's a patented beltless system. You can see on the far left there. It's a classic rack and pinion system, and what it does is it creates tremendous repeatability and precision, 10 micron positional tolerance. So that's a key aspect. You'll see that as the backbone throughout our platforms, whether it's the Plus Pro or the Argo 1000. I'll just touch on a couple of these. The insulated heated chamber. So when you work with highly viscous semi-crystalline materials like an Ultim 9085 or a Neat Peak, the most important component is a precise heated environment. So we get this chamber up to 180 degrees Celsius. You can kind of see, the different, I call it air holes on each side, but it creates a vortex within this insulated heated chamber that is precise. So that 180 degrees Celsius isn't on the far left. And getting a little bit cooler on the far right. Wherever you build in this heated chamber will create a precise and very neat semi-crystalline application like a peak. Next slide, Graham. And just a couple of, I'll just touch on a couple of these where when you work with super polymers, it's very important. And we have a very healthy paranoia with regards to preprint process and being very proactive with how we treat our materials. So on the far left, you have our high temperature filament dryer. That's essentially going to apply heat and compressed air to the filament or, the material in the machine. Essentially what that's doing is it's getting the material at its optimum state as it's fed into the machine. And the next component was the vacuum system. So making sure we have a very stable bed within this printer for that repeatable process. Next slide. The example we're going to talk about today in terms of the closed loop manufacturing component. And what we really focused on is our PA Pro material. But we built this application on the Argo 500, our flagship printer. So I just want to do a quick kind of dive on this. You can see build volume, how heated is the chamber. But I think the one thing I also want to touch on here is the versatility. So if you want to work with a high-end super polymer or a standard PLA, you have that capability with this printer. So you can extend your capabilities into advanced polymers. You can also do polypropylene if you so choose, if you have a flexible application. It's a really versatile platform to build on. Next slide. And this is the example we're going to get into today. So we talked about the closed loop manufacturing. The example we used, ROBOZE, is essentially the fixture associated. And I thought about this more and more because this is something we ran through our job shop at ROBOZE. But really what I want everyone to think about on this call is opportunity to open up the current machine capacity you have with more high value work. We see this consistently, which is, in order to get the precision on this part that you need, you're going to have to build a complex fixture, which also needs to be, machined, right? Machined out of aluminum. And with ROBOZE, you have the ability to build in a parallel way that fixture and open up your machines for more high value work. So this is an example of traditionally doing 100 parts within our job shop. And we focused on doing all the fixturing that we needed to do on the Argo 500. We increased the capacity on that machine by about 80%, reduced lead time by 35%, and the amount of maintenance on our CNC job shop, the machines that we had in there, by about 20%. So that's really something I wanted to focus on, is just, why would you want to bring in Argo 500 just for fixturing? And there's a range of reasons to do it, but there's a strong business case. And I know the team over at CAD-CAM has had experience in terms of machining with ROBOZE and the PA Pro. So I'm going to let them get into the example that we have teed up today. But again, any questions, I'll definitely be here for the entire presentation. So I'll let you take the next slide, Graham.
All right. Thank you very much, Levi. Yeah, it's good your dog is showing signs of life because mine clearly isn't. We're going to turn it over to Axel now, and he's going to talk about our application.
Thank you. Thanks, Graham. Thanks, Levi, for that intro. Let's jump right into our application. For those of you who do not know, a work holding is a extra part that is machined in general to actually create finished passes on your end user part. So it's mostly used to hold irregular shape parts that are made on a CNC machine. But the biggest challenge is you have to use your own CNC machine to cut these parts. And depending on the complexity of your original part, it could actually take longer to cut your work holding or your soft jobs. So, it limits, it ties up your machine. It's kind of limited in what you can do, can't do sharp corners. And end of the day, you lose a lot of time. And because of that, you lose money, right? So time's money. Next slide, please. So our solution was to 3D print these soft jaws on the ROBOZE Plus Pro and Argo 500 platform. And as you can see over here, the original putter head was 3D printed in metal, and it has multiple surfaces that needed machining. It was really easy to 3D print this part because we just designed it in CAD-CAM and we were like literally able to directly export it to the ROBOZE software and 3D print it. So what are the advantages of doing this? Could you go to the next slide, please? Well, first of all, it takes away the traditional constraints, right? You can go with super sharp edges. You're not using a CNC. That's the biggest advantage. So while you are 3D printing parts on the ROBOZE platform, your CNC machine is free to actually cut your client's parts. In terms of the strength, this is a super polymer, the Carbon PA Pro, and we were able to use something like 110 to 120% of spindle load on the work holding, and it worked fine. Another major advantage is lightweighting. So now instead of a big chunk of metal, you have plastic, so you can move it around easier. Also makes the environment safer. And many questions do come up in terms of tolerance. So from our experience, we were able to get the part down to 5,000ths of an inch. So that's super high tolerance just off of the machine. Now, of course, you can print these parts pretty fast on the Argo 500. And of course, if you can print, parts faster, you make more money. And the last biggest advantage, I would say, is that you're not wasting a lot of material by cutting away metal. You're just using exactly how much plastic you need for that work holding. So you do have less waste. Next slide, please. If you could run that videogram, please. This video actually shows you how the putter was oriented and the different surfaces that were machined. And as you can see, it was one work holding right there, and it was so easy to move the putter around. So that saves a lot of time too. So you don't have multiple work holdings just for one part. All right, next slide, please. Another advantage of the process was inspection. As you can see, the part was designed in the work holding itself was designed in CAD-CAM. We were able to quickly program the CMM using the same file on various software, and we were able to inspect the parts using the same work holding. So now you're saving time. You don't have to create another CMM inspection work holding. Use the same machining work holding, the soft jaw, and you inspect your files. So, you take away a lot of these extra steps, and you can inspect your parts faster, but you can, save more time, and more time means, you make more money. So that was some of the, major advantages of using the ROBOZE platform. Next, we'll get into some other applications using Carbon PA Pro. So next slide, please. One of the major areas that we are seeing adoption growing with the ROBOZE platform would be aluminum press forming dies. So you 3D print this entire part in one go on your machine, and you could use some metal tooling just for an insert, and there you go. You have a press die. One of the biggest advantage was production time. Generally, it would take anywhere from 2 to 3 weeks to get this tool made, and with your ROBOZE platform, you can just get it within 28 hours. So a crazy efficiency there. In terms of cost, we were able to save almost 40% per part. So almost half. And these parts have to go through some really strenuous operating conditions. Right? So there was almost 60 tons of weight applied on this specific part that was used for aluminum sheets. So I already touched base earlier that if you 3D print your parts, you're gonna have lightweight tooling. So that definitely makes your work environment safer. You can easily move things around, but also you can iterate more. So now you have the ability to 3D print multiple molds, so you can do smaller production batches for smaller order quantities. So that might open up your business to more diverse applications. What could those be? Next slide, please. One of them that's really picking up is thermoforming. So we have an application that used carbon peat that was used to thermoform plastic sheets, and the tool itself was made in carbon peat, and the requirement was around 10,000 cycles, and the temperature that was exposed to was 300 74 degrees Fahrenheit. So that's decently high with a lot of cycles. So really there's a value for money when it comes to the part that you're making. Another amazing application that we've come across is with carbon PA again for rubber molds, so rubber injection molds. And you could see right in the middle of the screen, there was molten rubber run right through these carbon PA Pro parts with the force being around 344 bars and almost 300 degrees Fahrenheit temperature. So that's a really interesting application. And also another advantage would be size, because the half per meter cube build volume of the 500, you can go for really big parts, you know. Another application I would really like to talk about would be, again, aluminum sheet forming, but using Ultem. Ultem, again, is a super high strength aerospace grade polymer, but it also can be used for forming and other type of tooling. You have very high tolerance on this part. So, you know, with the Argo 500, you're looking at, you know, 0.1 milli end to end, and that helps you get really accurate end parts using these tools. So next slide, please. And another very exciting partnership that ROBOZE has is with the Visa Cash App Formula One team. ROBOZE is one of the official 3D printing partner. And they have used the ROBOZE platform, particularly carbon PEEK, for a lot of their lightweighting and metal part replacement applications. The one that you see on your screen over here was a air duct, brake duct for, you know, air to pass right through it. And it was originally made in metal, CNC, and now they just 3D printed with carbon PEEK, and you know, they don't need to maintain you know, stock of these parts. So end of the day, they were able to save their lead time by 66% and their production costs down by 68%. So on a part-to-part basis, you know, the ROBOZE platform is really cost effective. Next slide, please. Yeah, earlier, Levi spoke a bit about Leonardo aircraft, and this is a very exciting application for metal part replacement that has come, you know, that we're showcasing. So if you can take a look on your right, the actual 3D printed part is the one in beige. But the original part was made in aluminum, in metal, right below it. And if you can, you know, see, there were multiple processes used to actually make this part. You know, they had to cut it, they had to stamp it, they had to bend it, and eventually weld it. So, and all of that was taken away, and you have this end part that was just 3D printed. That's it. And you know, the 3D printed in Ultem, you know, and Ultim has amazing properties for aerospace applications. The certifications are there. And end of the day, it was lighter than the original part. So if you're able to save weight on, you know, applications such as you know, aerospace or aeronautical, you're really going to create a lot of value out of these machines. So that's a great aerospace application that we have over here. So next slide, please. I've had a bunch of questions from you know, customers who ask, hey, how do I know what works for me? And my go-to questions would always be like, hey, could you tell me a bit about what the part does, what type of mechanical loads we're looking for, what type of environment you're going to put it into, and the thermal requirements. We can pretty much then match you to our portfolio of materials that we have over there. As you can see on your right, all our materials have a UL 94 flame, you know, V0 flame retardant rating, And I'll let Levi talk a little bit more about the certifications on
Yeah.
these cards. Yeah.
So just to hop in here, what we're talking about across the board, whether it's the examples we're showing or the closed loop manufacturing example is metal replacement. And when you start speaking about metal replacement, you need to make sure that you're backing this up with certification. We're one of the just to give you an idea of what we've done. We've gone after the hardest, most difficult industries to get into and try to replace metal. And that's incredibly difficult. It took a lot of time, but we've done a lot of development in terms of certification. So, as an example, in oil and gas, we're the only company to develop an API 20T standard for advanced polymer metal replacement. So we spent a tremendous amount of time working in these regulated industries, and really what we're doing is we're showing, the ability to replace metal in high heat, highly corrosive, and deliver the same kind of strength that people are looking for. So, if there's a certification that you need for the work that you're doing, we're always curious to hear kind of what that is and, where it might apply. But we spent a tremendous amount of time validating our materials in industry and in highly regulated industries.
Thank you, Levi. Thank you for that. Yeah, and that was about the application. And thank you for this. Now I will give it back to Graham and let him take it from there. Thank you.
Sure. Thanks, guys. So as we've mentioned, we have gone through this whole loop. We wanted to make sure that it worked. We wanted to test it out. We were skeptical. Rob is a traditional CNC machinist, works for us, has for 26 years, I think. And he ran through this project start to finish. So he's just going to kind of off the cuff talk about his experience with it and these materials and this machine.
All righty, thanks, Graham. Thanks everyone for showing up this morning. Yeah, I just want to talk about the whole process. Like Graham said, I was totally skeptical from the start. How am I going to hold this casting, if you will, in stainless steel in plastic? So so basically, what I found out after well, here, let me lay out the whole idea of the plan here. We wanted to be able to show off how do we hold a irregular shaped part, a casting. We came up with a putter. Like Graham said, it's recognizable. But what if I only had a 3-axis machine? How do I hold this part and hit all of the surfaces that have to be machined on the casting very easily and quickly? So the whole idea of 3D printing just was a no-brainer. If you look at this vise that we used the 5th-axis vise, but it's a 3-station 3 stations of metal that we would have had to machine. Not only that, each piece of that, the hard jaws or the middle hard jaw, would have had to be three different setups. Same with the 2 soft jaw or the 2 floating jaws. Those would have had to take 3 different setups. So the time that it would have taken just to machine those jaws for a part that's only going to have a couple of contours and a hole machined in it was just ridiculous. So the whole idea here was let's use the tools that we have. Let's digitize the whole process, keep it all in one file. So we started off and we took it into Verisurf, reverse engineered the part, used that model to design the soft jaws, save the solid models as a step file or even an STL model, and we sent that off to ROBOZE and they printed that on the Argo 500. So while that was being done, I could do the rest of the process while I was sitting at my kitchen table, basically, inside of CAD-CAM. Being able to set up, program the part, And another thing about this, about these jaws, is that part has a negative 3-degree draft to it in that picture on the left. Again, this 3-axis machine would never have been able to machine that. So with that in mind, I was able to encapsulate the part, program it, do the on-process or in-process inspection with Simco probing to find it, and then continue on. So what did I find out while I was machining this part? Well, one, it fully held the part. I also, which also meant that a lot of the vibration was taken out of the process. We talked about lightweight. That wasn't such a big deal for me, but on a 5-axis machine, that would be a big deal, right? You've got a trunnion that's moving around, and you don't want to add extra weight with on that trunnion. So that would make more sense. The jaws itself were extremely complex, but it was strong. I couldn't believe how strong it was. That surface we were testing to get that finish on the left of the putter face. When I looked up, and I think Axel had mentioned it, I looked up at the machine and it was at 110 to 120% spindle load. And I didn't even notice it because I couldn't hear, there wasn't any vibration. There wasn't any marring of the part that I would get from aluminum soft jaws. This slide doesn't really show it properly, but I ran an indicator over all of these, and again, I had to get all 3 of these jaws in sync. So yes, once we ran the indicators across all of it, it was within plus or minus 5 thou, which was perfect for this. As a matter of fact, the twisted casting was probably, it was somewhere between 30 to 60 thousandths twisted. So we were able to machine all of that back in and get that putter exactly the way we wanted it. Like I said, there's a slide that was shown earlier that had our logo on the back, on the bottom of the putter. If you look at that picture on the right, we machined that in another setup. So we're making that cut on the bottom of the putter, but then I flipped it over to the left and put it in another setup, and then I did the engraving. So the proof is in the pudding. If that wasn't repeatable, then I wouldn't have been able to get a clean engraving operation on that face on the left side of the fixture. So, the time that we saved, the money that was saved, was just incredible, and everything worked. And again, like I said, I started off skeptical, but the fact is we did use some really good tooling that was out there, with the 5th-axis rock lock that helped with the setup. I just had to drop it on the machine, but then we also had the rock lock for the CMM. So all I had to do was just unbolt the rock, or one screw, unlock the rock lock on the CNC machine, and I could drop it on the CMM. So again, no other way to fixture that quickly. And just keep in mind, this is another way of handling all of the different fixturing that you may have to do for the whole process, including now, and don't forget the inspection process. That's the biggest process, right? So why do something twice, and tie up your machine while you're making these jigs, these fixtures? I don't see any other way that you could get around a process like this and without the jaws. One added thing that I want to point out, that bottom or jaw, that one in that's facing the back of the machine, that's an oversized jaw. I had to make an oversized jaw. Now, if I would have just went to 5th-axis and ordered their soft jaws, this would have never worked. So think of the size of all of the material that would have had to been used, the aluminum that would have had to be used just to make a part that probably this whole process took a minute and a half to machine, which is ridiculous. We would have spent days trying to program all that. So kudos to ROBOZE. The technology is amazing. I can't say enough about how well this process worked out. I wish it would have helped Graham's golf game, but that's his problem. He'll have to work on that himself. Anyway, anything else? I don't know. Did we have any questions? I guess we're going to go to Q&A or okay. Well, thanks for joining us, people. I really enjoyed it.
All right. Thanks, Rob. Levi, I thought you were going to say something there, but you muted
Oh,
yourself.
I was just going to say, working with Rob and the skepticism is my favorite part of this job. I've been in this space for a little while, but we love this type of feedback. We do see this as a tremendous compliment and tool in the job shop. And so having that skepticism, understanding where it sits, we've built a platform around that. And so it's great to hear. And it's great to hear Rob's kind of perspective on using this. We see this consistently. And we've talked a lot about metal replacement. Another thing that, I always like to touch on is the machinability of our materials. Getting, there's so many different applications out there for, let's say, a peak application or a peak part. And that material is incredibly difficult to manufacture. And then you're essentially cutting away 85% of it to get to this final component that's going out the door. We do a lot of work with folks that are looking at just near net shapes and then finishing, the last, 10% of that to specification. That's a big application and a big part of what we do here is saving people a ton of money, whether that is replacing aluminum soft jaws or giving you a near net shape in a peak application that you just finish off to get to specification. There's a lot of things that we're doing in terms of lead time and saving people time and money with these materials and these printers.
Awesome. Appreciate that. Yeah, and I've known Rob for a long time. He's not the easiest guy to please, so that's a shining shining review. All right, I'm gonna bring it home. If you guys have any questions, feel free to type them into the chat while I kind of run through everything here. So first, we're going to talk about the technology with ROBOZE. It's being used in a lot of big names. We saw the F1 team there. A lot of different industries. There's over a dozen materials that are going to produce like metal counterparts. Standard techno super polymers. There's 3 different machines that are really going to scale with your needs. It can start small, move on up. There's a lot of technology in here that they've employed. And I hadn't heard the story before, but the fact that your founder created his own 3D printer when he was 17 years old that's awesome. That's really cool. So why take a look at this? I mean, beyond everything we've talked about in this webinar, you're going to free up your machines. You can focus those on your production runs. You can quickly produce parts. You can do R&D. It's a substitute for metal, right? It's lightweight. It's similar tensile strength. The cost of metal is going up. Don't know if you watch the news at all, but it's getting more and more expensive. They're certified for aerospace. That's huge. That was an incredibly appealing thing to me when we took this product on, because that's really like the number one thing you're hearing when, can you print aerospace parts? Yep, they can. They went and got certified. And overall, it's a complement to your existing process. So it's not replacing your subtractive processes, it's complementing them. And as was mentioned, we do have a Plus Pro in our office. We can print you a test part if you want to check it out. No problem. You can come and look at the machine. It's in Anaheim. We're not here to do your production runs. We're not here to print your runs, but just test the part out. One thing that's interesting is outsourcing 3D printing. It does take things out of your control. The back and forth with the company that you're working with, the shipping, it adds time. And they're doing it, you're not. So I love this quote. If you're currently outsourcing your 3D printing, you probably could have paid for the machine, by now, depending on the volume that you're doing. So Mr. Henry Ford had a really good quote here.
And just to add to that, Graham, we see that consistently with regards to outsourcing. It's the control, it's the time, but when you need to outsource a peak or a carbon peak or an Ultim 9085, the cost can be very, very high. So bringing that process in-house is very beneficial.
Awesome. So some links, you can find us on our website at CAD-CAM.com. I'm the marketing guy, so I'm going to encourage you to sign up for our newsletter. You can find ROBOZE at roboze.com. You can email us, marketing at CAD-CAM.com. Head up to our ROBOZE page on our website. There's a form at the bottom of it. We'll get a hold of you as quickly as possible. Both of our companies are all over social media. I encourage you to follow us both, interact with us, try to keep it fun up there. And then check out this recording. It will be on our YouTube page in the next few days. We do have a new playlist called CAD-CAM TV. So this is really, it is to house our webinars, but it's also to give you tips and tricks on all of our other products in a weekly, short form. So check that out. And then this whole putter, we actually wrote a 4-part article in a publication called Machine Design. So it really steps through this whole process with all the products, all the different things we went through. So go up to Machine Design and search for that article, those articles. There are 4 of them. Really good read. Next up, we have a Vericut webinar next month, April 15th, 9 o'clock. So that's a Tuesday. With the recording, we will send everyone that registered and attended or registered and did not attend a follow-up email with that recording, so you can pass it off to your coworkers, your friends, have a little bonfire and check it out. And every single webinar we're doing is kind of focused around this concept, but it's highlighting each individual product on a monthly basis. So be on the lookout for that. We can pause and take some questions now. We got a few extra minutes. Just want to thank everyone for joining us, and we hope you found it beneficial. We'll leave it open for like another minute or two. If we don't see anything, we're going to bail.
Hey, Levi, there was a question in the chat. I don't know if maybe you can address it.
So I believe the gauge of the aluminum is the question. So I've actually forwarded this on to our applications team who is working on this specific case with this customer. I just need to get an answer. I don't want to say something that's not true. My application engineers will slap my wrist. So I got to get back to you on that one, but I got you covered on that.
Awesome. Okay, I think we probably have answered everyone's questions. So that was excellent from you guys. Levi, Axel, Rob, thank you very much for your expertise. Thank you everyone for joining, and have a lovely rest of your day.
Perfect. Thanks, everybody.